Hi folks, Matt Easton here. Today we're going to be looking at how swords are made by Windlass Steelcrafts of India, one of the companies that it's been my absolute pleasure to work with in the last few years. One of the things that we've worked on perhaps most famously is the Royal Armoury's certified line of swords and other weapons. The first batch has been out for a couple of years and the second batch is just about to come out. We're working on the final prototypes of those now. It was my great pleasure to be a guest of the Windlass family and the business in April of 2023, and while I was there in the factory I got to film loads and loads of footage of how they make all of the magnificent swords and different weapons that they do. Windlass make things for many different companies, including themselves as well, trading primarily through museum replicas and Atlanta cutlery in the United States, and of course selling through lots of resellers all over the planet. So let's have a look at how swords are made at Windlass Steelcrafts in Dehradun in India. The Windlass company in Dehradun in India employs hundreds of people. Their facility is split into two main parts. What you can see here is the modern manufacturing part of the facility, which actually makes things for things like oil pipelines, and that is a very, very big part of their business as well as the building industry. But what you're interested in is sword making. So what we're going to be looking at today is how do they make swords in the traditional manner, heating up pieces of steel and hammering them and turning them into swords, knives, axes and pole arms. And this is how they started out their business in the 1940s. And of course that manufacture starts off with the steel, and when the steel arrives in the factory it has to be tested. So we're here at the moment in the testing department, and we're going to be looking specifically with Nimit here, and I've got Pradeep as well. And we're going to be looking at a spectrometer. So you were saying that every piece of steel...
Every piece of steel is inspected for the chemical analysis, so we are sure that it's 1080.
Okay, so 1080 for the blades, for example. So any of the metal coming into the factory.
Like even for axes, we use 1055.
Okay.
Because that's the most ideal steel for that.
Okay.
So we test that.
Yeah.
Brass coming in, copper to test the purity.
Yeah.
Because we are making our own brass. Yeah. We buy 99.99% copper and zinc, which are also tested for the purity, and then we mix them together in our furnaces. Yeah,
to whatever proportions is specified. Yeah.
And then we take the specimen of that also and test it for the exact analysis, like whether it's 8550 or what is the heat for that for us. Sure,
yeah, because different heat treating processes for different steel. So essentially we're going to look at the spectrometer, and is this a piece of 1080 steel? Yeah, so it's a piece of 1080 which is usually used here for blade steel at Windlass for swords, or 1055 as we heard for axes. So let's have a look at it. So Nimit, do you want to explain to us what we can see on screen here? Because I can see lots of elements and the composition.
Here we are going for different elements. Specifically we look for carbon, because basically the hardness depends on carbon and chrome. So its carbon is like 0.75. For 1080 there's a tolerance of 0.05. So it goes to 0.75 and then 0.85, that's a grade of 1080.
Okay.
And then we check for chrome, and chrome is also like here it's 0.1.
Yep.
And then the manganese. There's actually three special elements that we have to check is carbon, manganese and chrome. And once they are fine, then we approve the steel and put it in the production.
That's brilliant. Okay, well it's great to know that you're testing all the stuff and you know exactly what you're dealing with, and therefore, as you say, when you come to do the heat treatment, you know exactly what you're dealing with.
Because it depends on the steel also what temperature we have to do for the heat treatment.
Yeah, sure. Yeah. So there we go. And also I like the way that at the bottom of the screen it said 1080. So it tells you clearly. It tells you what it is. So you could put any piece of steel in here and it would tell you
what steel it is.
What it was. Yeah, fascinating. Great. Thanks a lot, Nimit.
Welcome.
Cheers.
Most welcome. Bye-bye.
And here we have the traditional forging. There's forging done in many different ways. Obviously the steel is heated up in furnaces, and it can either be hand hammered or it can be machine hammered. As we see here, traditional hand hammering is prevalent throughout the factory. and also the use of power hammers of various sorts. These power hammers are not completely modern invention and were used traditionally. They were formerly steam powered and before that water powered. And these go back hundreds of years and were used in Europe, all over Asia, India, China, Japan. So it's a completely traditional way of forging sword blades. The steel is taken out of the furnaces and taken straight to the hammer where here we can see a tang being formed. So the worker is holding the blade in this case, and it's the tang that's been heated up and is being drawn out. This is a completely traditional way of manufacturing a sword blade. Once the blade's been forged, it goes to grinding, and that's where the close to the final surface is ground. The blade is ground down, not to its final thickness or thinness, but certainly the final shapes are started on the blade with the edge bevels, the fullers, the point. So this is really the next natural stage that comes after forging. Here we see belt sanders being used, but grinding wheels would have been used traditionally. This is a very much traditional way of shaping sword blades. Many different types of sword blades being shaped here. Everything from rapiers and long swords through to sabres. We can even see axes and falchions and various other sorts of things there, spearheads. You'll notice that various different wheels are used, different size wheels are used for different angles and different purposes. And the craftsmen are always stopping to look along the blades and check the lines of the work that they're grinding into those blades. It's amazing to see the speed and skill that these workers go with. They churn out hundreds and hundreds of these things, and they are so specialised to each task. Again, we can see different sizes of grinding wheel being used. They're electric powered now, but originally would have been water powered or even foot cranked in some cases. These kinds of wheels can be seen going back hundreds of years. Here we see a fuller being ground in. So this is essentially doing the same job, but with a different type of machine. This is a way of putting a very precise bevel, or in this case fuller, onto a blade. Here we see lots of blades that have been ground and prepared for the next stages. There are vast amounts of storage at the Windlass facility. All Windlass blades are heat treated, and it's a proprietary process, so therefore I didn't film it. But basically you've got quenching and tempering done with state-of-the-art technology and testing. And of course, once the blades are heat treated, they have to be tested. So these blades are first quenched to harden them and then tempered. So they achieve a springy result, and they have to be shock tested like this. Now this is based on the Wilkinson sword testing, smacking the blade onto a wooden block to check that it can sustain that shock and is not too brittle. Any imperfections in the blade in terms of the steel or indeed the heat treatment would break a lot of blades at this stage. So obviously a broken blade gets discarded. This is another type of test which again comes from the Wilkinson and standard British testing method, which is testing the flex in a very controlled manner with this big lever that pushes into the blade and forces a certain amount of deflection, and then when it's brought back the blade is pulled out of the jig and it is checked by the staff member there to check that it has returned exactly to true and is not bent out of line or anything like that, to check that it has the requisite degree of hardness and tempering to it. And the next blade goes into the jig and the process is repeated. All of the sword blades which are intended to be functional being made at Windlass are tested in this way. They're shock tested by being beaten on a wooden block, and they are flex tested. Of course, blades that don't meet the criteria are discarded. Blades are also tested for their hardness, and this is a machine that essentially pushes a hardness measure into the blade to test for the hardness of the steel and to check that it is the requisite Vickers or Rockwell hardness on the surface of the blade. The blades are also checked for straightness, and here you can see filing of the shoulders of the blade and tang junction and the tang form itself. Very important because the tang can be a weak point, especially where it meets the blade, and so they're very careful about how that's done. Here we can see polishing, in this case of some scabbards. So similar to grinding, but here a soft wheel, a cloth or felt wheel with a polishing compound on it is used to polish the surfaces. And this is done on blades as well as scabbards. Here we can see a load of Conan's father's blades, I think they are, as well as some more scabbards there. And here we have some partisan heads and axe blades and various other things. These are all polished. These steel objects have all been heat treated already and are being polished in very similar ways. You have to make sure you don't overheat the object when you're polishing it, of course, because that would mess with the heat treatment. Some more grinding there. Grinding and polishing obviously being closely related activities. There are other ways of polishing metal objects, which we'll see in a little bit. And here we see a load of heat treated and polished and ready to be mounted blades, axes, swords, scabbards even, and they're being quality control checked. And this is a very, very big part of the production line process at Windlass. They are churning out hundreds and hundreds of these items on a weekly basis, and so they have to have very strict quality control. Here we can see a sax blade which has got all of the etching and polish, and it's basically ready to have a hilt fitted to it. And once they've been quality control checked, obviously they're put into groups. Here we can see wood which is prepared for various things such as grips, scabbards, and even firearm stocks. We can see some stocks for firearms down there. And here we can see some lathes which are shaping, I think, are probably wooden handles, and a similar machine which cuts things out as well. So a lot of this is automated, but of course it is still all put together largely by hand. There are lines and lines and lines of these machines. Here we've got lots of wooden grips for all different types of knives and daggers. And these are examples that can be copied. So these can be put into the machine, used as a model, and you can make 100 more of them. This of course ensures that you have hundreds and hundreds of grips which are exactly the same as each other. Here you can see the sword grips being shaped. And the jig allows you to shape multiples in one go, even though they are fundamentally a human-operated machine. There's lots of grips ready to be mounted up, lots of sword grips, bare wooden grips, and even rifle stocks. Various different wooden objects. Every type of wooden object you could think of is being manufactured in this room, and the smell of the wood is fantastic, I have to tell you. There we have got some knife handles, grips being screwed on. So they're bolo knives, and they're being screwed in the traditional manner as they would have been 100 years ago for the US military. They're being bolted onto the tangs prior to final shaping. So at the moment you can see the wood is roughly shaped. Here we've got some kinjals, and they've also been mounted, and again what will come next is final shaping before the wood is stained. And here we've got scabbards as well, because of course the same wood is being used for scabbards, and also shafts for poles, for pole arms, and clubs and maces and things like that, axe handles. And here we've got some very nifty walking sticks with mace-like heads. So every type of wooden object you can think of that is incorporated into weapons or anything to do with the historical artifacts being made here. There's some more sword grips ready to be covered. They're all being made in this workshop, and it smells lovely with all wood. Here are some shields which are actually being dried in a special sort of room, which is essentially like a hot room, drying out room, where the wood is both being seasoned and shields are being glued into shape. And of course, once they've been glued into shape in a plywood construction, they are ready to be painted. And here we can see essentially the primer coat going on. Many shields are sold in this form to be painted with heraldic devices later on. And of course the fittings for scabbards and hilts we're going to look at here. Let's see, how are these brass fittings made? So brass fittings are very important for lots of types of sword. Obviously we've got pommels, we've got guards, we've got scabbard fittings. It all starts off with a certain mixture of brass. Now you'll see some numbers written on these pieces of paper. You see 63-37, you might see 80-20. These are mixtures of brass, essentially, so zinc versus copper being the two main components. And different militaries and different types of sword use different compositions. And here we've got the wax. So the wax is very important. So these craftsmen, very, very detailed work here, are carving the wax formers, and these are what's going to provide the basis for the mold. So here we can see guards and pommels being carved expertly, beautifully, and then attached to sprues. So we see a whole, almost like a tree, a whole load of pommel caps there for French and American style swords being attached to a sprue. Here we've got some guards and some other hilt parts. And once they're on the sprue, they need to be covered in ceramic. So they're put into this sort of cylinder. And here we can see the workers are mixing up the ceramic powder, essentially, which is going to be liquefied. The sprues are put into this cylinder container, and tape is wrapped around so that the ceramic is not going to leak out. They basically make it watertight. And then they're put into these large containers where the liquid ceramic is going to be poured in. And when the lever is pulled, the cylinder underneath is filled up with liquid ceramic. And as you can see, so those wax models are now inside the ceramic, and that is then, once the ceramic is hard, it's heated up and the wax pours out, creating a void inside. So you now have inside that ceramic, this is known as the lost wax process. The wax has poured out, so you're now left with a perfect void inside, which is ready to have the molten copper and tin and zinc, so the brass or bronze poured into. And once it's poured in, it fills the void and creates these absolutely marvellous castings. Still on a sprue, just like a model kit you might buy to build. And the sprues are discarded, and of course they can be remelted and reused, so they're separated into their different compositions for the different regulations. So different militaries actually have different brass compositions that they require. And all of the brass that, as you can see here, they just pour it back in, put it back in where it's melted and used again. So they do also use the massive crucibles as well, and this was very, very exciting to watch, and I have to say very hot. So as a British person in India, the weather there was fairly warm. It was like a hot summer's day. The hottest it gets in Dehradun is actually only about 38 degrees Celsius, but nevertheless inside this factory near to this red hot glowing crucible containing molten brass, it was pretty hot. So the crucible is moved into this carrying device, and then the workers, and this is completely and utterly traditional. I mean, this is the way that bells and cannons and Bronze Age swords have been made for hundreds and indeed thousands of years, going all the way back to the Bronze Age. And the molten metal is, you'll notice a little bit is decanted into a smaller crucible. This is so that they can fill the molds from both ends at the same time, because obviously they have to do this fairly quickly. While they're pouring, that molten metal is cooling down, and while it's cooling down it's becoming less ductile and it will flow less well. So you have to kind of pour it while it's as hot as possible to give it the best chance of getting a good cast inside the mold. And you can see there's molds stacked in lines, in fact one above, one below, and they're pouring the molten brass into those holes, which fill the void which was formerly filled by wax, which was melted out and leaving that perfect rendition of the wax former inside. And you can see the smaller crucible is pouring from the other end, so they're going to meet in the middle essentially. They're pouring from both ends to fill up those molds as quickly as possible while the metal is as molten as possible. This was quite mesmerizing to watch. There's nothing quite like glowing molten metal in my books. And then of course the molds are broken apart because they're not needed anymore, and inside they have the brass castings, in this case of hilt parts for a naval sword, I think, by the look of it. So we've got a brass guard, we've got the back piece, we've got the pommel, so essentially all of the brass components that you need for the hilt of your sabre. And obviously the guard is beaten into shape from there because it's flat at the moment. Here we've got all of the parts, the pommel parts for a shashka, various other guards for different types of sabre, pommel parts for French sword there, French cavalry sword, 1896 pattern. And there you can see they've been bent into shape, and they have to then of course be polished and ground, because in many cases the casting has a rough surface. So again, we're back to grinding and polishing just as we were with the blades, and this is done by hand on wheels, exactly as it would have been done 100, 200, 300 years ago. And we've got various different brass fittings, guards, scabbard parts, pommels, back pieces, everything you can think of. You can even find the tops for walking sticks, buttons, buckles, all kinds of stuff. Absolutely fascinating. And here we've got some steel hilt parts as well. We shouldn't forget that many hilts are made of steel and scabbard parts are made of steel, and they're of course made usually by filing and welding and forging, just like blades are. But they still have to be polished and ground in the same way as the brass hilt fittings. So you can see here, we can see steel hilt and scabbard parts alongside brass and bronze hilt parts and scabbard parts as well. Because at this stage, they now all need to be finished. They need to be polished up and in some cases gilded or coated or plated. So here we can see the craftsmen working with very fine little tools to enhance the delineation and the finish of those edges and those grooves and the decoration, because casting sometimes can result in quite a rough finish, so it needs to be enhanced by further handiwork up close with these rotary tools. Here we've got some rapier guards, you can see various sabre guards. And I was really surprised by how much work goes into enhancing the decoration on the brass castings. Also, they have to grind out and polish anything which interacts with the blade to make sure that the guard will seat well against the blade and the blade will sit into the groove or the hole through the guard or the pommel, for example. Now this is another way that things can be polished. It is a tumbling machine and they put different types of stones and materials into the tumbler depending on what they want to polish. And here we can see spearheads actually being finished. So these are spearheads which have been rough ground and they are being given a, shall we say, a kind of satin finish by the tumbling machine, and I was really amazed by the result. You literally throw spearheads in and out come the spearheads. Here we've got the wooden grips again, so let's have a look at how grips are fitted and made for the swords. So we've got our blades, we've got our hilt parts, now we've got to apply these wooden grips, and here you can see shagreen or shark skin has been applied to these wooden grips and bound with wire, and it's drying. So it was applied and glued on when it was soaking wet and is now shrinking and drying to the shape of the grip. Here we've got the wire being made, so wire wrapped grips on sabres, for example, military swords. It has to be twisted, and they've got this amazing machine. It looks a bit like a sewing machine to me, that is specifically designed to make the twisted brass wire which gets put on military sword grips. And they've got all different kinds of settings and different gauges of wire for different models of sword. So if you're looking at a French army sword, it has one type of twisted wire. If you're looking at a British cavalry sword, it has a different type of twisted wire. Some of the wire's copper, some of it's brass, some of it's silver, some of it's gold plated. So all different types of wire bound in all different ways. And here we can see the wire actually being applied to the grip. So this is a grip which has had leather applied to the wood. That has all set and been dyed dark. Now the wire is being wrapped around by the craftsman by hand in exactly the same way as it would have been done 100, 200, 300 years ago. It gets snipped off at the end, and then the end of the wire gets poked into a hole and essentially pegged into that hole so it can't come loose. This was actually quite mesmerising to watch. I've restored quite a few antique swords in my time, and this is a really fussy and difficult job to get done well. You've got to keep the wire under a lot of tension to make sure it's tight, and then keeping it under tension while you peg it into place is really difficult. So watching this craftsman doing it, it looks so easy for him because he's such an expert at what he's doing. He does it day in, day out, and he is absolutely specialised in this task. Also, of course, ferrules need to be shaped to the top of the grip. So brass ferrules are usually cast round and then they're hammered to fit the grip underneath. And finally, all the hilt parts are mounted together. They can either be peened or screwed or riveted, various different ways. But here we can see a selection of different swords that are straight off the factory floor basically, and axes as well. And of course leatherwork is a big part of this, because leather goes onto many of the sword grips but is also used extensively for the scabbards. So Windlass has an entire part of the factory is devoted to leather processing and production, manufacturing of all sorts of leather products. Obviously scabbards, even clothing, and here we can actually see some shagreen or shark skin, ray skin being prepared for naval swords, and you can see that the worker is scraping the back to make it really thin, which helps it mount onto the grips well. Once the leather is all stitched and mounted, it has to be dyed and then obviously be allowed to dry out. So there's one part of the workshop which is entirely for scabbards being finished off, and here we can see a laser machine being used on wood or indeed on the blades itself. So when you see that little Windlass Steelcrafts mark or Royal Armouries mark, this is often how it's applied with laser etching. And of course they also do more traditional forms of acid etching as well. They use a resist, in other words something which resists the acid etching process. This is facilitated also with a type of UV light activated, and then it's put into the acid. This, I'm actually not certain of what form of acid. It's probably ferric chloride or something like that they're using. But essentially this is absolutely traditional style acid etching. And then once the swords are finished, they are brought into the workshop and they are checked for the final fit and finish, and in many cases the hilts have their peening done. So here we can see some hammering on the end of the tang to tighten up the hilt for the final peen. And not all swords are peened. Some swords have a nut at the end. Sometimes the nut is countersunk, sometimes the nut is hidden. Sometimes hilts are riveted laterally onto the tang. Here we can see some Conan's father's swords and some French gladiuses. Various types of ceremonial sword. Windlass makes swords for most major militaries of the world, as well as lots of other organisations, including Masonic swords, university graduation swords. Absolutely all sorts. A lot of French, British, American military swords are made here, as well as of course more medieval style swords for various other lines, not just for Windlass but for other manufacturers or sellers as well, who get things manufactured for them by Windlass. Here we can see some Grossmessers and some Henry V style swords. And there we've got the scabbards as well, which are usually kept separate from the swords. And here we've got some of the Royal Armouries line. Now, the Royal Armouries line go through extra stages of testing. And here we can see at the final stage here, once they've been fully mounted, this is another test that Wilkinson used to do before they declared swords ready for being sent out, basically, to customers. And that is, once the hilt's been mounted, they are bashed on a wooden block to check for rattles, to check for movement in the pommel or the grip or the guard. And of course, this is an extra degree of testing for the blade heat treatment as well. So the swords are beaten on a wooden block which has a leather covering on it. The leather covering is there to protect the blades from picking up any nasty scuffs or scratches. And this is one of the absolute final levels of quality control, as we can see here on some of the Royal Armouries swords, which I obviously worked on a lot myself, and I took all the measurements of the originals in the Royal Armouries, and that's what's being made here. Here they are. I was very happy with how this sword turned out. I've featured this in various videos, and I consider it a fantastic armoured fighting sword. And of course, once the scabbard and the sword are ready to go, they are wrapped. The scabbard's wrapped in paper, the sword's wrapped in plastic, and they are fitted, in the case of the Royal Armouries sword, in very elaborate boxes. At Windlass, absolutely everything is done in-house, even down to making the boxes for shipping. And there we go. One of the Royal Armouries Windlass swords made with me, ready to ship out to you right now.